In this lesson, we're going to determine whether the series converges or diverges. That is, we have to determine if summation n equal to 1 up to infinity n factorial divided by 5 exponent n converges or diverges. If we let x sub n equals n factorial divided by 5 exponent n, then x sub n plus 1 equals n plus 1 all factorial divided by 5 exponent n plus 1. That is, whenever we see n, we will replace it by n plus 1. Now, we are going to find the limits as n approaches positive infinity of the absolute value of x sub n plus 1 divided by x sub n. This gives n plus 1 all factorial divided by 5 exponent n times 5 exponent 1, which is the same as 5. Remember, if you have a exponent m plus n, it is the same as a exponent n times a exponent m. So this one gives divided by n factorial divided by 5 exponents n. This implies that we have the limit as n approaches positive infinity, the absolute value of, now n plus 1 factorial is the same as n plus 1 times n plus 1 minus 1, all factorial, and 1 minus 1 is 0. So we'll be left with n plus 1 times n factorial. So we are going to replace n plus 1 all factorial by n plus 1 times n factorial, all divided by 5 exponent n times 5 divided by, then we turn n factorial divided by 5 exponent n upside down to get 5 exponent n divided by n factorial. So here n factorial will cancel n factorial, and 5 exponent n will cancel 5 exponent n. So we'll be left with the limit as n approaches positive infinity, the absolute value of n plus 1 all divided by 5. Now, we can factorize 1 over 5 out to get the limit as n approaches positive infinity, the absolute value of n plus 1. This gives 1 on 5 times the limit as n approaches positive infinity of n plus 1. Now, as n approaches positive infinity, we have 1 on 5 times positive infinity plus 1, which is equal to 1 on 5 times positive infinity. That gives us positive infinity. Now, from the ratio test, if the series, that is summation n equal to 1 up to infinity x sub n with x sub n not equal to 0 is such that the limit as n approaches positive infinity, the absolute value of x sub n plus 1 divided by x sub n equal L, then the series diverges if L is greater than 1. And here, since infinity is greater than 1, the series diverges.